In this video, we are going to study gamma function. Now, what is gamma function? Gamma function is a special function which is defined in terms of certain integrals which cannot be evaluated by usual methods. These are typically improper integrals. Now, what is improper integral? The first integral I1, which is integral from 0 to infinity of x e raised to minus x dx, is improper because its one limit is infinite. The second integral I2, which is integral from 0 to 10 e raised to minus x upon x dx, is also improper because its integrand tends to infinity as x tends to 0. Now we will define gamma function as an improper integral from 0 to infinity of e raised to minus x into x raised to n minus 1 dx, which is denoted by symbol gamma n. Now this improper integral is convergent for positive values of n, which means gamma n approaches a fixed real number. Gamma function can also be remembered as gamma n plus 1, which is integral from 0 to infinity of e raised to minus x into x raised to n dx. The only difference here is when there is n here, there is n minus 1 here, and when there is n plus 1 here, there is just n here. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. We will deduce a property of gamma function. We have defined gamma function n as integral from 0 to infinity of e raised to minus x raised to n minus 1 dx. Now we will replace this n by n plus 1. That will give us integral from 0 to infinity of e raised to minus x into x raised to n plus 1 minus 1 will be just n dx. In order to apply integration by parts, we will write this integral as first x raised to n into e raised to minus x dx. Now by integration by parts, this can be integrated as first function into integration of e raised to minus x from 0 to infinity minus integral from 0 to infinity of derivative of first, which will be n x raised to n minus 1 into integration of second from 0 to infinity of e raised to minus x dx. Now this will be x raised to n into integration of e raised to minus x will be e raised to minus x upon derivative of minus x minus 1 from 0 to infinity minus integral from 0 to infinity of n x raised to n minus 1 into integration of e raised to minus x is minus e raised to minus x dx. Now this we will rewrite as gamma n plus 1 equals minus x raised to n e raised to minus x from 0 to infinity plus this minus and this minus will become, we will rewrite this step gamma n plus 1 equals minus x raised to n e raised to minus x from 0 to infinity minus integral from 0 to infinity n x raised to n minus 1 into minus e raised to minus x dx. This will be minus x raised to n upon e raised to x from 0 to infinity. This minus and this minus will become plus into n integral from 0 to infinity of e raised to minus x into x raised to n minus 1 dx. Now here, value of this part of the integral at x equals 0 will be obviously equal to 0. Now in order to find its value at x equals infinity, we will take limit x raised to n upon e raised to x as x tends to infinity. In order to solve this limit, we will use L'Hopital's rule of continuous differentiation of numerator and denominator. So this will be limit derivative of x raised to n is n x raised to n minus 1, derivative of e raised to x as x tends to infinity. We can go on finding derivatives of numerator and denominator and successive limits of them. We will finally get limit n factorial upon e raised to x as x tends to infinity. As x tends to infinity, denominator e raised to infinity will approach infinity, which will finally take this limit to n factorial upon infinity, that will be 0. So therefore value of this part will be 0. So we will get gamma n plus 1 equals this n, and now this part by definition is gamma n. So we get property of gamma function, which is gamma n plus 1 is n gamma n, which also implies gamma n equals n minus 1 gamma n minus 1. Gamma n equals n minus 1 gamma n minus 1 can be further interpreted as n minus 1 into n minus 2 gamma n minus 2, which will be n minus 1 into n minus 2 into n minus 3 gamma n minus 3, so and so forth, and finally it will be gamma n equals n minus 1 factorial, which according to definition of integral from 0 to infinity of e raised to minus x raised to n minus 1 dx, we observe that there is n minus 1 here and n minus 1 here too, which implies integral from 0 to infinity of e raised to minus x raised to n dx equals this n factorial. So gamma n equals n minus 1 factorial, and integral from 0 to infinity of e raised to minus x raised to n dx is n factorial are two important interpretations of property of gamma function. Now let us understand how to evaluate gamma n. First we will see how to evaluate gamma n when n is positive integer. For example, gamma 5 will be 5 minus 1, that is 4 factorial, which will be 4 multiplied by 3 multiplied by 2 multiplied by 1, that will be 24. Gamma 3 will be 2 factorial, 2 multiplied by 1 2. Gamma 2 will be 1 factorial, that will be 1. In order to calculate gamma 1, we have gamma n plus 1 equals n into gamma n. That means gamma n will be gamma n plus 1 upon n. Accordingly, gamma 1 will be gamma 1 plus 1 upon 1. That will be gamma 2 upon 1. But gamma 2 is 1. So gamma 1 will also be 1. On the same lines, what will be gamma 0? That will be gamma 0 plus 1 upon 0. That will be infinity. So we have obtained two important relations. Gamma 0 is infinity and gamma 1 is 1. Secondly, we will see what will be gamma n when n is a negative integer. For example, gamma minus 4 will be gamma minus 4 plus 1 upon minus 4. That will be gamma minus 3 upon minus 4. That will be further gamma minus 3 plus 1, that is gamma minus 2 upon minus 4 into minus 3. That further will be gamma minus 2 plus 1 gamma minus 1 upon minus 4 into minus 3 into minus 1, which will be gamma minus 1 plus 1, that is gamma 0 upon minus 4 into minus 3 into minus 2 into minus 1. But since gamma 0 is infinity, gamma minus 4 will be infinity. So this shows that when n is negative integer, gamma n is infinity. This can be easily shown by repeated use of gamma n equals gamma n plus 1 upon n. Next we will see how to evaluate gamma n when n is a positive fraction. For this we will use gamma n equals n minus 1 gamma n minus 1 repeatedly. For example, gamma 7 by 2 will be 7 by 2 minus 1, gamma 7 by 2 minus 1, which will be 5 by 2, gamma 5 by 2. That will be 5 by 2. Again applying rule for gamma 5 by 2, it will be 5 by 2 minus 1, 3 by 2, gamma 3 by 2. That will be 5 by 2 into 3 by 2. 3 by 2 minus 1, 1 by 2, gamma 1 by 2. So gamma 7 by 2 will be 5 by 2 into 3 by 2 into half into gamma half. What will be gamma 15 by 7? It will be 15 by 7 minus 1, 8 by 7, gamma 8 by 7. That will be equal to 8 by 7 into 8 by 7 minus 1 will be 1 by 7, gamma 1 by 7. Now we will see how to evaluate gamma n when n is a negative fraction. For this, we will use the rule gamma n equals gamma n plus 1 upon n. For example, we will evaluate gamma minus 5 by 3. That will be gamma minus 5 by 3 plus 1 upon minus 5 by 3. That will be gamma minus 2 by 3 upon minus 5 by 3. This can be further calculated as gamma minus 2 by 3 plus 1 upon minus 5 by 3 into minus 2 by 3. That will be gamma 1 by 3 upon minus 5 by 3 into minus 2 by 3. We have obtained gamma 7 by 2 equals 5 by 2 into 3 by 2 into half into gamma half. Gamma 11 by 5 equals 6 by 5 into 1 by 5. Gamma 1 by 5. Gamma minus 5 by 3 equals gamma 1 by 3 upon minus 5 by 3 into minus 2 by 3. We observe that there is gamma of proper fraction in the answer, which means n lies between 0 and 1, and these gamma functions need to be evaluated by numerical integration. Out of this gamma half works out to be root pi, about which we will learn later on. So we conclude that gamma n is defined for all positive integers and not for 0 and negative integers. And when n lies between 0 and 1, then gamma n is evaluated by numerical integration. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.